Hello and welcome to the second lesson in our differential equations chapter. This one is slope fields. So slope fields often, if you were wanting to have a giant massive slope field for a differential equation, you would not do it by hand. There are softwares out there that can make these for you, and this is not something we would spend here making a giant slope field by hand. This is just to go through the process of making a small slope field to give you an idea of what they are, how they work, and how you can therefore visualize different solutions to a single differential equation depending on an initial condition. So first, what is a slope field and how do we sketch one? So a slope field is just a selection of very tiny lines that each have their own given slope, and it will create a field of these little tiny lines. So you'll have these little tiny line segments all over your grid, basically. And then you can place a curve that follows the slopes of these little tiny lines and basically guides where you're going to draw your curve. Where your curve goes depends on the initial condition you are given. So essentially, all of these slopes will match your differential equation. And you know that a differential equation has a dy dx in there somewhere, or y prime. And a reminder that a y prime is just a slope of a tangent line. That's all that is, right? So you're essentially creating all these little mini slopes of tangent lines and these little tiny segments of tangent lines to a curve that you don't have. And so the differential equation is something that, unless you have the solution, you have an infinite number of solutions that could work if you are not given your particular solution. So when you're sketching a slope field, once you have the field, you're usually asked to also sketch a curve to draw in at a given initial condition. So you're given a point to start with, and you draw your curve where you follow all of your little tiny tangent lines. And essentially, at any given point, your tangent line should be able to attach to your curve and work. Like, it should make sense what it looks like. So you shouldn't have a curve, for example, that's decreasing with a tangent line that's increasing. That wouldn't make any sense. So how do we sketch a slope field? And this hopefully will make more sense once we get into it and we start trying a few problems. Basically, at each xy, at each point, we're going to draw a short line segment. It's not going to go through your whole grid. It's going to be short, like maybe a centimeter long. Okay. Your collection of line segments creates your slope field for a given differential equation. Now you might be going, okay, well, how do I determine my slopes? Well, your slopes are going to be determined by your differential equation. So if your differential equation has just x's, then at each point xy, you're just going to need the x coordinate, plug that into your differential equation, and that will give you the slope that you should have at that given point. If your differential equation has both x's and y's, you're going to need to plug in the x and y coordinate of every point separately and get a new slope for each point that would then correspond with that differential equation. Okay. So we're going to try one here, and hopefully this will help make sense out of your slope fields. So we have a differential equation, dy dx equals 2x. This is our differential equation, and we're going to sketch the slope field for this differential equation. So in order to do that, we need to figure out at each point in our grid what is the slope of our line segment that we are going to draw. And we're going to do that by using the differential equation. So for A, if we want to sketch the slope field for the differential equation, if I pick, say, this point here, this point is 1, 1. Okay? So for example, at 1, 1, dy dx equals 2x. So this is going to equal 2 times 1 because your x coordinate is 1, which gives us 2. Okay. So the slope at 1, 1 should be 2. So I find it helpful to actually kind of temporarily draw another point and then use that to help me figure out how steep my line should be and then get rid of the point I drew to help. Okay? You don't actually have to draw that point down. It might just help to kind of visualize it and visualize and kind of visualize yourself going straight down, but not actually drawing it on your page. Okay? So when I say short line segment, I mean short line segment. It should not reach a second point anywhere. It's kind of like floating in midair, just touching that one point. Now, hopefully we notice since your dy dx is equal to 2x, it only depends on the x coordinate of your point. So anytime my x coordinate is 1, my dy dx is going to equal 2 times 1, which is 2. So everywhere that x is 1, I can draw a line segment that has the same slope as the one I just drew. Once you kind of get into a groove of them, it makes it a little bit easier to keep just repeating your same slopes. Now, if I pick another point, let's say I pick at 0, 0, dy dx is 2x, which would give me 2 times 0, which is 0. And this is going to be true, again, for any time x is 0. Okay, so anytime x is 0, my slope should be 0. So I'm going to go through and I'm going to have little tiny line segments with slopes of 0 everywhere x is 0. And we can continue with this. We're going to do, let's say at negative 1, 0, dy dx is going to be negative 2. So we draw in these little line segments with a slope of negative 2. And you can see that those should be look kind of opposite to the blue ones that I drew earlier. And now, I mean, we could fill up this entire grid, but this is going to take us a long time. So I usually like to start at, say, 1, 0, and negative 1. And then I'm going to take a look at my point and kind of see where else I need to go. So if I take a look at this point here, I have an x value of negative 2. So I don't really need any more on this side of my grid. What I really want is I want some more on the other side of the green section. So I'm going to try if x is negative 2. dy dx would be negative 4. So I'm going to have slopes of negative 4 when x is negative 2. So these ones are going to be a little trickier to draw. Eventually, if the slopes are too steep, they kind of all start looking the same. So just do your best. So 1, 2, 3, 4. Okay. And then I'll probably do one more, again, further to the left. I'll try if x is negative 3, then dy dx is going to be negative 6. So this is going to be super steep. Let's see, over 1, 2, 3, 4, 5, 6. So if I go like that. So you can see it's even steeper than the black one, but eventually it's hard to do them by hand so that they actually look accurate. Okay. And when you're actually making your slope fields, I mean, you do not need to show all this work here. You can do that in your head. It might be handy to put down 1 or 2 just to make sure that you're on the right track and you're not making some stupid math mistakes in your brain. And once you think like, hey, I think I've got enough short little lines, I'm going to try sketching my curve. My given point, we've done part A, sketched a slope field for the differential equation. Okay? Part B is to sketch an approximate solution of the differential equation of the slope field passing through the given point. So my given point is at negative 2, 3, right here. That means that when I draw my curve should follow the slope field so that at any point, if I look at my curve, the tangent lines that are represented by these little slopes should make sense. So I shouldn't be going down like this. That wouldn't make sense. None of these tangent lines would work for that curve, which means that this curve does not work for my given differential equation. So I can see that if I were to head to the left, this thing should head up. between essentially my tangent lines here, so that the slopes of these tangent lines would work roughly with the direction and steepness of my curve. If I were to head down to the right, I can see that it's going to head down towards the right. Then there's a part where my slope of my tangent line is 0. So that means that my curve should reach some sort of maximum or minimum. And then it would head back up towards the right. Okay. And I could be more accurate on the right had I kept going and drawn more tiny slopes over here. If I had been given a different point, my curve would look slightly different. Now, it's not going to look too different. If I think about this differential equation, I have y prime equals 2x. So what y would work for this? Well, if I think about this, if I take the antiderivative and I do y, my equation should be x squared plus c. Well, that's essentially what I've just drawn here. I've just drawn a parabola, x squared, and the plus c is your constant that's going to change where this parabola goes, up, down, along my axis, right? And this point that I've been given, I was given the point negative 2, 3, has to work inside this equation. So if I actually plug this point in, I get 3 equals negative 2 squared plus c. Or c equals negative 1. So y is equal to x squared minus 1. So this just tells me that I wasn't super accurate on my curve drawing. I probably should have gone down a little farther. I should have followed this down farther, like this. Okay. And again, if I had a different initial point, my c value would have been different, which would change where my curve lies. So the initial condition is basically helping us figure out what the curve looks like for this slope field a bit more specifically than just picking any random point and drawing one in. So if I had been given this point here, my curve would have been down here like this. So once you have your slope field is the collection of little lines. The particular solution that we've drawn for this initial condition is this red curve that we've drawn here. Let's try another one. A differential equation and a pointer given, sketch the slope field. Sketch an approximate solution of the differential equation of the slope field passing through the given point. Okay. So in this case, we can see that our differential equation is just equal to y, which means that our slope is going to equal whatever the y coordinate is of our point. So if I'm doing A, let's say if y is 0, then dy dx is just going to be 0. So when y is 0, we're going to have little lines with slope 0. Okay. If y is 1, dy dx is 1. Okay. So if y is 1, we have slopes of 1. So use the other points. Don't just randomly guess your slopes, because then your sketches are not going to be accurate. If you're planning on taking an AP exam, they do need to be close. Like they can't be just completely random slopes of lines. Like, hey, my slope is positive, I'll just draw some sort of positive looking line. You do need to attempt to make them an actual slope of 1. So if I'm trying to draw a slope of 1, for example, at this point here, I know that another point that would be on that line, if this line continued to be here, and so if I draw my line through those two, there you go, there's my slope of 1. But then I shouldn't have the entire line, I should just have one section, and I shouldn't actually have a point. So use the other points on the grid to guide you. Okay, I would do the same thing for the next point, for example. The next point here, that means that my line should come through here. There's my slope of my line. So it should be close. It shouldn't be just like, hey, I'm going to do some random, like, sure, that looks kind of like a slope of 1. Well, is it a slope of 1? If not, then that is not your accurate slope field. Your slope field has not been done correctly. Okay. So we need to keep going. We'll do if y is 2, then dy dx is 2. So again, you don't have to write this down over here every single time. You can just kind of do it in your head. So if y is 2, again, see, I'm going to pick this point up here and use this to guide myself down to the point I actually want to draw at. And once you've got a couple of them, you can kind of just look at your previous lines and go, okay, that's the shape I should be drawing. Then if y is 3, we're going to have a slope of 3. So we should see that these are getting steeper as we go. And again, I mean, we can fill up the entire grid, but we don't need to because we can take a look at where we're actually going to draw our point. So we're trying to draw our point at ln 3 and 6 is where our point's supposed to go. So you could plug this into a calculator and figure out that this is about 1.099. So the point that we're trying to draw at is just over 1 and 6. So this is the point roughly where we're trying to draw our curve at. So we need some more points up in this general area to figure out where we're going, but we don't really need any points way over here. We don't need any points way down here. We can leave those alone. If you're taking an AP exam, usually it's 9 points that they'll give you. They'll give you a grid with 9 very distinct points at which they want you to draw your slope field at. So at 4, our slope should be 4. At 5, our slope should be 5. And yes, it will get a little bit difficult to do these by hand. That's why it's not common that you would actually do an entire slope field by hand. You would be likely using some sort of computer software to do it if you're wanting a really, really giant slope field. So we can see here that we've got this point and we want to be following our curve. Oops. We can see that it should be decreasing as we head to the left. Increasing as we head to the right. So this looks like some sort of exponential graph. Okay, let's try another one. Another word for a slope field is a direction field. So if you see that word direction field, this is what they're referencing. Okay. Okay. So again, sketch an appropriate solution. My suggestion would be to maybe pause here and try this one on your own. And then come back, and if you want to walk through the steps, go for it. If you want to just fast forward or scroll forward to the appropriate point where you can just see the solution, that's fine. If you're still not feeling quite comfortable with this, then you can keep walking through with me. So here we've got our differential equation. Again, this is just regarding our x. We don't need y in here. We've got ln x over x, so x is the only coordinate that matters to us. So if x is 1, for example, we're going to have that dy dx is ln 1 over 1. Ln 1 is 0, so this is going to equal 0. So if x is 1, we have a slope of 0. Hopefully you'll notice that x cannot be 0 here. You would have a slope that does not exist. If you want to draw vertical lines to help you out, go for it, but your slope does not exist there. If x is 2, dy dx is ln 2 over 2. You can go ahead and plug that into a calculator and get approximately 0.347. So if x is 2, we're going to have a slope of about a third. x is 3, dy dx is going to be ln 3 over 3. And you can go ahead and plug that into a calculator. You get about 0.366. So again, about a third, but maybe slightly steeper. And if x is 4, then dy dx is going to be ln 4 over 4. We're doing ln 1, by the way. At 1, negative 2 is where our point's going to be. This ends up being 0.347 as well. And I mean, you could try something like 1/2 if that helps. You could do ln 0.5 over 0.5 if that's helpful for you. If you do that, you should get a pretty a negative number that's pretty steep, and it'll end up looking kind of like this. So let's go ahead. I believe if x is 0.5, you get dy dx is approximately negative 1.4-ish. Okay. So if I try and draw this in, my point is at 1, negative 2, right here. So because we have this x can't equal 0, that's essentially your asymptote. So this is going to head up like this. And to the right, this is just going to go ever slowly to the right because these slopes are all very close to being the same. So it's essentially going to guide your curve kind of in that direction for quite a long time there. You could try when x is 5, 6 if you want to add more points in this area, but this would be fine. All right, this next one. This is a typical grid that you would see on an AP exam. This is about how big their grids are going to be. They want you to draw, okay? So we want to just sketch the slope field here. We aren't doing anything past that, just sketching the slope field. There's no curve that we're going to be drawing in for this one. Okay. And you'll see that this uses x and y. So the coordinates of the point, it's not going to be as fast as the previous ones, okay? We do know, however, if x is 0, then dy dx is going to be 0. Okay? And we can see that if y is 1, dy dx would also be 0. So those ones are easy to draw in. I suggest doing that if you've got one that uses x and y. Figure out first, like, for what value could you get a slope of 0? Draw all those in and then do the more complicated ones. So we've got 6 points left that are a bit messier. So we've got at 1, 0, then you'd have dy dx equals 1 squared times 0 minus 1, which gives us negative 1. That's this one here. At 1, 2, dy dx is going to be 1 squared times 2 minus 1, which gives us 1. At 1, 3, dy dx is going to be 1 squared times 3 minus 1, which gives us 2. At negative 1, 0, dy dx is going to be negative 1 squared times 0 minus 1, which gives us negative 1 again. Okay, and then we've got at negative 1, 2, because negative 1 is squared, that should be the same as 1, 2. This should be 1. And same thing when we do at negative 1, 3, because the x coordinate is squared, that should be the same as 1, 3. This is going to equal 2. So these ones are a little bit more complex because you do have to consider both x and y. So they take a little bit more time. Again, if you're writing an AP exam, this is about the size of the slope field they usually tend to give you. So I would suggest pausing and doing the next one by yourself, and then coming back to this and scroll forward if you need to, if you don't want to walk through all the steps. Again, if you're still feeling like you're not quite sure, you can stay with me and walk through each of the steps. So we're told that x cannot be 0, so that means we don't have any points that have been given to us where x is 0 anyways, and we're not going to have any slopes there. But we know that if y is 1, then dy dx would be 0 because you'd end up with 0 on the top of your fraction. So we can draw those ones in at least nice and quickly. Okay. So then we need to do each other point separately. So at 1, 0, you get 0 minus 1 over 1 squared, which gives us negative 1. At negative 1, 0, because the x is squared, you're going to end up with the same thing. You're going to have 0 minus 1 over negative 1 squared, which is also negative 1. So we can, when we do any of these coordinates, the opposite x value is going to end up with the same slope as the previous one we calculated. So that will save us a little time. So 2, 0 is going to give us 0 minus 1 over 2 squared, which gives us negative 1 over 4. So 1, 2, 3, like that. If we had to do negative 2, 0, we'd end up with the same thing, but we don't. Okay, we've got 2, 2. So we're going to get 2 minus 1 over 2 squared, which gives us 1 over 4. And we've got 1, 2, which is going to give us 2 minus 1 over 1 squared, which gives us 1. And so when we do negative 1, 2 are also going to get 1 because, again, we're squared on the bottom. And that is it for this section.